Hey everyone, so today we're going to be going over the Unit 8 review. I'm actually going to work through the assignment with you guys so that you can see how to work through these specific problems step by step, and you'll have this resource available for whenever you go to take your test. So first thing we're going to talk about is scale factors and dilations. Remember when we talked about scale factors, anytime k is greater than 1, you are going to have an enlargement, okay? And then anytime k is between 0 and 1, we are going to have a reduction, or our image is going to get smaller. So here in the first example, if a figure is dilated by a factor of 3, the perimeter of the triangle is going to, or the perimeter of the image is going to be what? So we have our options 1 and 2 over here. So dilated by a factor of 3, that means we're going to get bigger. Okay, so we are going to triple the size of our perimeter, or make it 3 times the size of the original figure. So 3 times the size. Okay, and then for the second one, if a figure is dilated by a factor of 1/3, the perimeter of the image is going to be what? So again, 1/3, whenever you have a scale factor that's between 0 and 1, this is supposed to have 1 right there, you are going to be making your image smaller, so you are reducing it by that scale factor, that fraction right there. So your image will be 1/3 the size of the original figure. 1/3 the size. Okay. For number 2, we are looking at a coordinate plane. So here the figure shown on the coordinate plane is reflected about the line y equals x, okay? And then it is also rotated in a 90 degrees clockwise direction. So here we technically have 2 different types of transformations. We have a reflection first, and then we also have a rotation. So what we're going to do, we're going to have to move it 2 times. So let's do one motion at a time. So whenever we're reflecting, okay, in y equals x, so reflection of y equals x, that's going to take your original coordinate of xy, and you're going to move it to where your new coordinates will become y comma x. So first, let's start off and just find out what the value of p is initially. So p is at 6, 3. Okay, so 6, 3 is our starting point. So when we reflect, this is going to be our step 1. Okay, so we're going to take our point 6, 3, and then we're going to reflect across this y equals x, okay, and so we're going to take our x and y values and switch them around. So our value of p prime is now going to be 3, 6. So this is p prime, all right? But remember, we are doing 2 different transitions, 2 transformations. So we have just done the reflection, so p prime is now at 3, 6, okay, but now we still have to rotate it in a 90 degrees clockwise direction. So let's go ahead and plot our point of p prime, right? So that is 3, 6, which is right here. So p prime. All right, and now let's go ahead and start step 2. So step 2 is a rotation, okay, and we are rotating 90 degrees clockwise. So I have a reference sheet available for you guys, but for a 90 degrees clockwise rotation, the rule is that you're going to take your x and y values, and then you are going to change them to become y negative x. Okay, so a 90 degree rotation is going in a clockwise direction, so rotating this way. Okay, we're going to switch those values from xy to y negative x. So find the value of p prime, which we just determined was 3, 6. Okay, and then now when we rotate it clockwise, we will have 6, negative 3. And when you put it on the coordinate plane, look at that, it moved down in the direction of our 90 degrees. Okay, so 6, negative 3 is our location of p double prime. Okay, so continuing on, now we are are looking at a perimeter with pre-image and image. So in this situation, what is the perimeter of the image? So we're given a pre-image right here. We're told this is 45 inches. So let's highlight this. So our pre-image is 45 inches. We want to know the perimeter of the actual image, so the blue. So we're going to go green to blue. Okay, in order to find that, first we need to find our scale factor. Okay, so our scale factor is going to be the ratio of our image to our pre-image. Okay, so when we're looking at that, technically we actually want to look at the distance from the image to the center. Okay, so we're going to be looking here at this line right along here. So from the image to the center, we have a distance of 12. Okay, so my scale factor is going to be based on this distance here. For my pre-image, I have to go from back here all the way down. See how it starts at 6 here, but then we also go over this 12 inches for the image itself? In this case, the distance from the pre-image to the center is technically 6 plus 12, or 18. Okay, so we can also reduce this scale factor. Okay, if we divide both by 6, top and bottom, we're going to get a scale factor of 2/3. So k equals 2/3. Right, now that we have our scale factor, we can say our scale factor, 2/3, equals, again, this ratio of our image to our pre-image in relation to the perimeters. So I'm going to take my perimeter of my pre-image, which is 45, and I'm going to take the perimeter of my image, which I'm actually solving for, and set up this proportion. Once we're here, you are going to cross multiply, so we get 3x equals 2 times 45, which is 90, and then when we divide both sides by x, or by 3, we get a value of x equals 30. So when you have a scale factor of 2/3, okay, if your pre-image has a perimeter of 45, your image will have a perimeter of 30. There we go. Okay. Continuing on to number 4. So here the triangle below is dilated by a scale factor of 2. So let's highlight that. It's probably important. Okay, dilated by a scale factor of 2, and it's also dilated about the point -1, -1. Okay, lastly, it's also translated up 4 units. So here we have 2 different things going on, okay, but the key is that our center is -1, -1. Okay, so what are the coordinates of point T after our transformations? So here we're going to take into account that our center is at -1, -1. So the first thing that we want to do is dilate by using our scale factor. So step 1, we want to dilate, all right? But the key to this, remember, if your center is not at the origin, technically you have to count to see how much you would have to move. So in this case, if our center is at -1, -1, we're going to go 1, 2, 3, 1, 2, 3 to get to T. So we go down 2, let me scoot this down a little bit. All right, so we're actually going to go down 3 and then to the left 3. So if we were to look at this as from the origin, even though our point starts at -4, -4, if we take into account this center being 1 less, -3, -3, okay? So -3, -3, in order to dilate, all right, we're going to have to double, okay, so dilate by a scale factor of 2. So k equals 2. That means we multiply movements by 2. So down 3, left 3 will become down 6, left 6. So if we start from our center, we're going to go down 1, 2, 3, 4, 5, 6, and then left 1, 2, 3, 4, 5, 6. So this is going to be the location of T prime. Okay, so that part is done. All right, done. Okay, but now step 2, we still have to translate up 4 units. So for a translate up 4, we're just going to say x, keep your x value, but then we're going to add 4 to our y value. Okay, so we're going to go up 1, 2, 3, 4. All right, making our t double prime, or both transformations, at a new location of -7, -3. Okay, moving forward. All right, so here we have a heart. Point Q is translated left 4 and up 2, and then reflected across the x-axis to point Q prime, double prime. What are the coordinates of the original point Q? So this one, make sure if there's a question like this on the test, you are paying attention to what the question is asking. So here it says, what are the coordinates of point the original point Q, but when you look at the graph, this is actually Q double prime. So if we're at Q double prime, okay, so Q double prime is at -6, 1, okay, we want to get to Q, all right, that means we technically have to work backwards, okay, so on this problem, we're going to be working backwards this way, okay, because here, look, point Q is translated left and up, and then reflected to the final point. But if we're starting at our double prime, we want to reflect first. So let's highlight that. We're going to reflect across the x-axis first. If I can get my highlighter. Okay, so step 1. And then we will translate. Okay, step 2. But remember, if we're actually working backwards, this has to be right 4 and down 2. And we'll explain that a little bit more in a second. But first things first, our first step is going to have to be to reflect across the x-axis. So we need to get from Q double prime to Q prime. Okay? So the order that we're technically going in is Q double prime, Q prime, and then point Q. Okay? So for our first step, we want to reflect across the x axis. Okay, so whenever we reflect across the x-axis, again, you can look at your transformation rules sheet, right? Anytime you have a reflection across the x-axis, your x and y coordinates are going to change to x, comma, negative y. Okay, so if Q double prime is at -6, 1, then we need to make Q prime, because we're working backwards, -6, -1. Okay, so this is going to be Q double prime. Or Q prime, there we go. So Q double prime, ending to the middle step, Q prime, we are now at -6, -1. Okay, see how we're kind of going backwards a little bit? So step 1 is done. We've reflected across our x-axis. But now we need to do step 2. Okay, so step 2 was a translation. Okay, so in the problem, it states that we want to translate left 4 and up 2. But that's when we're going from the original point to the final point. Now we're going backwards, so technically we want to translate right 4 and down 2. Okay, because again, we are working backwards. Okay, so what's going to happen? If you want to use the rule for vector translations, we could say 4, -2. All right, and then if you use this in XY format, x comma y, you are going to go x plus 4, y minus 2, okay? So what's going to happen if your q double, or your q prime right here is this -6, -1. When we add 4 to our x value, we're going to have a new point of -2. And then when we take 2 away from our y value, we have a -3. So again, if you want to do it manually, we're going to go right 4, 1, 2, 3, 4, down 2, right here to -3, okay? So let's put this point right here. So q prime, or point q, right? So this is the value of q. Okay, so your answer for this would be -2, -3, all right? But if you really want to check, follow the rules, okay? If we did this correctly, starting here at q, following these directions in this order, we should end up at q prime. So if we translate left 4, 1, 2, 3, 4, and up 2, 1, 2, we should land at q prime. We did. And then when we reflect across our x-axis, so we're at -6, -1, we need to go to up 1, okay, q double prime. So definitely be sure which way your question is asking you. Are you starting at the end and need to go to the beginning, or are you working in the other way? Okay. So almost done. All right, so if a point xy is translated 3 units left and 7 units up, which of the following is the correct transformation? So this one should be pretty straightforward. We're going 3 left, that's going to be your x value, and then 7 units up is your y value. So we need to subtract 3 and add 7. Okay, so x minus 3, y plus 7 is going to give us an option of C. Right here, PQR is rotated about the origin according to the transformation given here. XY maps onto -x, -y. So if R is originally located at -2, 7, what are the coordinates of R? So here we're just going to follow the rules. So if we start at -2, 7, we need to make our x value negative. So we're going to have a -2, which is positive, and then a -y would be -7. So R prime would be at 2, -7, or A. Okay. So here EFG is similar to PQR, right? EF is a value of 3, FG is 7, PQ is 9, and PR is 12. What is the scale factor from EFG to PQR? So in this one, you could technically map out the parts, right? I like to draw pictures because I personally am a visual learner, and it doesn't hurt to have pictures, right? So here, if we have EFG, all right, label it out. EF is 3, FG is 7, and then we have PQR. So notice I'm putting the vertices in the same point. So E relates to P, F relates to Q, G relates to R, just like my similarity statement. Okay. And then PQ, they tell me, is 9, and PR is 12. Okay. So in order to find the scale factor, right here, we want to find corresponding sides. So notice here, 3 and 9 are in the same position, however 7 and 12 are not. So we're going to use 3 and the 9, okay? And then look at the order that we're going, EFG to PQR. So we're going EFG to PQR, okay? Remember, scale factor is going to be your image over your pre-image. Okay, remember, pre-image is actually your starting point. So we're going to say PQR over EFG. Okay, or 9/3 when you're comparing those sides. Okay, so your scale factor is going to be a total of 3. And if you look at it, if you go from E, F, G to P, Q, R in this order, 3 times your scale factor of 3 is 9. Okay? So next, write a proportion to solve for given the following similar figures. So all you're going to do is look at these corresponding sides. Okay, so there are different ways we could write this, but ultimately you just want to compare similar sides. So 3 and 7 should be on the same ratio, and 5 and x plus 4 should be. So let's just go left to right. Okay, so I'm going to say small over my large is going to equal small over my large. Okay, so I'm just using my corresponding sides. 3 over 7 equals 5 over x plus 4. So let's see if we have one of these. 3 over 7 is 5 over x plus... Oh, that worked out. Okay, there we go. All right, but if we double check the rest of these, so let's say 5 over x plus 4, so look at option C. 5 over x plus 4, so small over large, equals 7/3. We're actually going in the opposite direction, so that wouldn't work. Okay, if we compare the other ones, so 3 over x plus 4, 3 over x plus 4, those are not corresponding sides, so that will not work. And then 7 over 5, again, they are not corresponding sides, so that will not work either. Okay. All right, down here, describe the sequence of transformations from ABC to A double prime, B double prime, C double prime. So we're starting right down here in this purple triangle. All right, so we're going to go from ABC up here to A prime, B prime, C prime, and then we need to move to A double prime, B double prime, C double prime. Okay, so if we look at our first motion from here to here, notice that your image kind of flips, all right? It flips across that x-axis, all right? This is what we call a reflection in the x-axis. Okay, so first movement, we have a reflection in our x-axis. Okay, so that's going to put us right here. And then for the next one, see how it kind of just slides across our coordinate plane? I personally would pick a point, so I'll pick B prime. All right, and then C, find where B double prime is. So let's count. So I go from here to here, so it looks like I go up 1, 2, and then 1, 2, 3, 4, 5, 6 to the right. All right, so this, since we're sliding across our coordinate plane, this is called a translation of, all right, and then remember we said we went up 2 and then right 1, 2, 3, 4, 5, 6. Up to right 6 to our B double prime. Okay. Last two things I wanted to talk about really quickly. We have reflectional and rotational symmetry. Okay, so reflectional symmetry, it can be like folded in half. It has multiple or singular lines of symmetry. So the easiest way to think of this one, reflectional symmetry, if you have like maybe a starfish, my starfish isn't going to be perfect, all right, or I think one time we did an example of the letter K, and again, these are hand-drawn, so they're not perfect. Technically, a starfish would have, if you folded it in half right here, these sides map onto each other. Okay, so map onto each other. All right, so a starfish would have, gosh, this one's not perfect, technically 5 lines of symmetry. The letter K, if you fold it right down like horizontally in half, the top would map onto the bottom, if this was a perfect K, all right? Let's see, if we had a, Okay, this one. All right, so this image specifically would not have reflectional symmetry, okay, because technically, if I draw my line horizontally, we have this little triangular thing up at the top that won't work. Okay, so no, yes, yes. Okay, now rotational symmetry is where you can rotate it, can be rotated to map on. All right, so rotational symmetry, one really good one would be maybe an addition sign. So technically, if we rotate this 90 degrees, okay? So if I was to honestly take this and copy it, okay? If it were perfect, in a perfect world, if I was to rotate this image, okay? See how we rotated it? Well, technically that would be a 90-degree rotation, not 45. Okay, and then if we rotate again, it's still cross-shaped. Okay, and then we rotate one more time. See how it's basically the same every single time you rotate it? That is what rotational symmetry is. Okay, if you have something like I don't know, this thing, that would not have rotational symmetry. Okay, it would just have to have a full rotation. With rotational symmetry, it has to be able to rotate just a portion. Okay,